Artificial intelligence. Instead of being adaptive, defense is purely reactive. In most cases it involves or essentially consists in limiting or foregoing some functionality. When a new attack has been discovered, more often than not the security solution consists in reducing the functionality. One major reason to turn toward AI, is to put an end at the present situation. The move from DNS to InSec illustrates somewhat the problem with the present approach. It has improved the security of the Internet. But the cost is a complicated system of keys, whose renewal opens the door for scenarios of failures, which did not exist before. With InSec the Internet is less vulnerable to malicious exploitations of the weaknesses of the DNS system, but the use of a cumbersome system of authentication for all the servers involved does not make it more reliable. The world of web applications is growing fast in importance and size, but in parallel it raises increasing concerns about security, which will not be solved adequately within the present paradigm of defense. Same Origin Policy, SOP, is another example of the old-fashioned approach to cybersecurity. SOP, a policy adopted by most browsers, was designed to prevent the possibility that scripts originating from other than one site can be run on a website. Admittedly, this has potentially dangerous consequences. Not only attacks such CSRF show that it is possible to circumvent the same origin policy, but that policy blocks other functionalities, which could be useful. In the words of Douglas Crockford, allows dangerous things while preventing useful ones. The way out of that dilemma may lie in a much more intelligent defense. In the case of CSRF, the proposed defenses are either in the website, alerting the system administrator that the website in its present design allows CSRF attacks, or in the client side. Typically the solution suggested either reduce the functionality of the website, changes the protocol of trusted session by requiring more authentication, or, as is the case with Request Rodeo, offers a tool which limits partially the access to websites from the clients. In other words, the solutions tend to make the protocols safer by making them more cumbersome, and the protection often involves a reduction of functionality, i.e. it goes exactly against the logic, which underlies the success of the Internet. What an AI-based approach potentially offers is a way to address the multiple threats associated with cybersecurity, without having to rely on an increasing list of changing rules or security procedures for diagnostic and recovery procedures. If security tools were expert systems, which could not be abused as easily, the situation would be very different. Ideally they would understand what users are trying to do and make sure that this is what is happening. They would develop a sense of situational awareness, from which they would be able to tell malicious activity from legitimate ones. They would be able to make context-dependent determinations. If AI means introducing intelligence in an automated system, there is no doubt that the future of cybersecurity lies in AI. But AI is at the same time an advanced field and at a very early stage of development. The limits of the possible with AI are not known. The limits of the capabilities of AI are a moving frontier. In a post-biological intelligence world, P. Davis, 2010, the division between natural and artificial intelligence will be blurred. We are still far away from that world, but it is not too early to envision it. And the question is, how should AI be introduced in the world of cybersecurity with maximum effect in the short term? Should we have a vision of AI-based cybersecurity as a cyber equivalent of what happened with the immune system during biological evolution? I.e. of the creation over time of a large and complex organ inseparable from the rest of the organism? Should the first phase attempt to build the equivalent of a rudimentary immune system, with a vision of an eventual large and sophisticated one? Or should the search be more random and based on trying to introduce more intelligence in security tool whenever possible and wherever possible? In fact, the two approaches differ only on paper. The immune system must have developed out of a random search, as we are told the rest of biological evolution, leading in the long run to high levels of organization. To what extent does AI in its present state provide a framework to start building such a system? It is impossible and not useful here to try and describe a field like AI. On the one hand, it is a large body of academic knowledge, Russell and Novik 2003. When it comes to its applications, it looks more like a vast and fragmented field. Through expert systems, AI has found applications in numerous fields, from medical diagnosis to helping manufacture to finance management to fault analysis to advanced optimization, and to a too limited extent to cybersecurity. Of the many techniques used in AI, when it comes to anomaly-based intrusion detection, the techniques, which seem the most natural, are either statistics-based, Mitchell 1997, or knowledge-based, Kerkar and Srinivas 2009. The whole area of machine learning tends to make heavy use of statistics. The a priori caveat with that kind of approach in the context of intrusion detection is the possibility that the problem, or curse, with false positive reemerges. If it is possible to set up the system in such a way it can reason probabilistically, Pearl 1988, about events along the lines of the iterative Bayesian updating described previously, this problem may turn out manageable. Statistically based machine learning traditionally needs huge amount of data. This may turn problematic in many situations of interest for intrusion detection. This points to the fact that there are fundamental cognitive differences between human beings and machines. Human beings need much less data to learn than machines and get a better power of discrimination. One implication of that remark is to invalidate partially the assumption that what human beings can do, machines will also be able to do. Still, an approach based on statistical learning in cybersecurity is not hopeless, quite the opposite. But this suggests that the best use of AI may not be to try to find a way to have machines replicating what human beings do. An alternative to statistical learning is knowledge-based systems, KBS, Kerkar, 2009, although that approach raises also challenging issues. KBS tends also to be specialized. The system can acquire its knowledge in a variety of ways. It can be made to learn. A lot rides on the way knowledge is stored and represented. Those systems can reason and make inferences. In principle, they could be used to make autonomous determination of whether a malicious attack is unfolding. In practice, in the case of web applications, for example, the information they have is what the browser sees, HTTP requests, they can parse ad nauseum, website contents, etc. One immediate challenge is to set up a knowledge base, which can make sense of such information. Other approaches used in AI may turn out quite powerful in cybersecurity. Intrusion detection has some features in common with problem solving. Techniques using formal logic and theorem proving may turn out to be quite useful. If it were possible to reformulate the problem of intrusion detection as solving a logical problem, we would know better what the limits of the possible are. As of now, probabilistic reasoning seems to be the most natural and easiest way to introduce AI in intrusion detection, but this may not be the only one in the long run. In the context of cybersecurity, AI applications could take several forms. But it is clear that to be useful, any AI will have to be used intensively. Even if the processing power of computers is increasing impressively, one has to be concerned by the potential CPU overhead associated with any intensive AI technique. Considering that there is hardly any alternative in the long run to AI in cybersecurity, one has to be prepared to see cybersecurity to be part of the rest of cyber in the same way as the immune system is part of the animal's organisms. Instead of being a protection added at the end, it will be an integral part of the system, and as is the case with the immune system, it could be made dual use. I.e., its function may not be limited to protection.